Hi everybody, in this video we're going to go through the review sheet for test number 2. So question number 1 says using the construction below, state the degree measure of angle CAD in the triangle and to explain why. So if you take a look at the construction marks for constructing the triangle, you'll notice that arcs of equal lengths were used to create the triangle, making the triangle an equilateral triangle. So I'm going to write that down. Let me use a color, equilateral. Sorry for my messy handwriting. It's a little bit hard to write on my computer here. So we have an equilateral triangle, and we know that if the sides of a triangle are equal, the angles opposite those sides are equal as well. So if a triangle has 3 equal sides, it's going to have 3 equal angles. Since all the angles in a triangle always add up to 180 degrees, we can do 180 divided by 3, because there's 3 angles in the triangle, to figure out what each of the angles is going to measure. And we should get that each angle of the triangle is 60 degrees. Now, the question is asking us not for the angle measurement of angle A altogether, but it's asking us specifically for angle CAD, which is right over here. CAD, A is in the middle, so we're talking about this piece of the angle right over here that I outlined in pink. So if you take a look at the construction marks that are on the whole angle, this first arc over here, and then these 2 arcs over here, you might notice that this is the construction for an angle bisector. And if you don't remember what the construction for an angle bisector is, take a look at your constructions packet. If you don't have it, it's posted on Google Classroom under Unit 1 classwork. It's titled Constructions Packet, and it's type number 5. And you can see the steps for constructing an angle bisector, and you'll see that it's the same as what's happening to angle A here. Since the angle is being bisected, it's being cut into 2 equal parts or split in half. So if the whole angle A is 60 degrees, 1/2 of angle A will be 30 degrees. So angle CAD will be 30 degrees. So we can write that here, 30 degrees. The question does say explain why. Your explanation should be in words. It could be something of the sort, since the triangle is equilateral, all of the angles measure 60 degrees. Since angle A is being bisected, it's cut into 2 congruent or equal parts. So angle CAD is 30 degrees. You can write that however you want, as long as you fully explain why angle CAD is 30 degrees, because the question is asking for the degree measure of angle CAD. In question number 2, it tells us that the measures of the angles of a triangle are in the ratio 2 to 3 to 4. And it's asking us for the measurement of the smallest angle. So let me underline that, the smallest angle. So in questions where they're talking about a triangle or some other shape and you don't see a picture, a really good idea is to draw your own picture. So I don't know anything about this triangle. All I know is that I have a triangle because it tells me that we have a triangle right here in the question. And I know that the angles are in the ratio 2 to 3 to 4. Remember that when you have a ratio, any ratio, but here we have 2 to 3 to 4, you can rewrite, there we go. You can rewrite each part of the ratio as follows. You can write the 2 as 2x, you can write the 3 as 3x, and you can write the 4 as 4x. So I don't know which angle is which in the triangle. It didn't tell me. So let's say this is the 2x angle, this is the 3x angle, and this is the 4x angle. Clearly, the 2x angle is going to be the smallest angle in this triangle. And the 4x angle is going to be the biggest angle in the triangle. And the 3x angle is going to be somewhere in between the other 2 angles. The question is asking me for the smallest angle. So once I figure out what x is, I can plug in to 2x. I can substitute whatever I get for x and multiply it by 2 in order to figure out what the smallest angle of the triangle is. So I'm going to make an equation that says this angle of the triangle, 2x, plus this angle of the triangle, which is 3x, plus this angle of the triangle, which is 4x, is equal to 180 degrees. Once again, this is because anytime you have any triangle, no matter what kind of triangle it is, all three of the angles added together always make 180 degrees in any triangle. Combining like terms, 2x plus 3x plus 4x is 9x, and that's equal to 180. Dividing by 9 on both sides, I get x is equal to 20. So the question didn't ask for the x value, it asked for the measure of the smallest angle, which is the 2x angle. So I'm just going to substitute our x value of 20 in for x. So 20 times 2 makes 40 degrees. So the measurement of the smallest angle would be 40 degrees. And you can plug in your x value for the other two angles, and you should see that they're bigger than the 2x one. 20 times 3, that would be 60 degrees, bigger than 40. 4 times 20, that would be 80 degrees. That's bigger than 40 as well. So the 40-degree angle is the smallest angle in this triangle. So the first thing I'm going to do for question number 3 is take a look at what information they're giving me to work with in the question. And I see right away that they tell me that line AB is parallel to line CD. So as soon as you know that two lines are parallel in your question, start thinking about the angle relationships that we learned about when parallel lines are cut by a transversal. You know, the alternate interior angles, corresponding angles, same side interior angles, all that stuff. Lesson 7, you can check it out if you need a reminder or refresher on that. Uh-oh. There we go. I keep clicking buttons. So I'm going to keep that in mind, that I'm probably going to have to use one of those angle relationships somewhere. So let's take a look at what the question is telling us and figure out where we're going to go from here. So it says from point E on AB, so I see point E, it's right over here. Transversals EF and EG are drawn. Oh, the word transversal. So we're definitely going to have to use our angle relationships formed when parallel lines are cut by a transversal. They're giving us lots of hints here that some of those angle relationships are going to show up in this question. They also tell us that EF, ray EF and ray EG are drawn. I see that in the diagram. I see ray EF and I see ray EG. And it tells us that they intersecting lines CD at H and I respectively. So that's just there to tell us how the diagram is set up, basically. So we know that the measure of angle CHF is 20 degrees, and they put that in for us in the diagram already, so we don't even have to do that. That's really nice of them. And the measure of angle DIG is 60. Once again, they filled that in for us, so that's very nice that they did that. We don't have to fill that in ourselves. And we're looking for the measurement of angle HEI. So HEI is in the middle. So this is the angle that we're ultimately trying to figure out. So what you should do is think about any relationships, angle relationships that you see here. The first one that jumps out to me is vertical angles. Take a look at the 60-degree angle. This angle over here, EIH, right over here, shares a vertex with the 60-degree angle. They come out at the same point. They look like they're opposite from each other. Remember, vertical angles come out at the same point, and they're not right next to each other. They look like they're across or opposite from each other. So I know that vertical angles are always congruent. So if this angle is 60 degrees, the angle that's vertical to it will be 60 degrees as well. We have another pair of vertical angles right over here. You check out this 20-degree angle. It comes out of the same point and looks like it's across from angle EHD right over here. So once again, vertical angles are congruent. So I'm going to fill in 20 degrees. They are the same measurement. Vertical angles are always congruent to each other. Now, let me think about more angles I can fill in here. So there's multiple ways now to get your answer. And I was sure in this question we were going to have to use angle relationships formed when parallel lines are cut by a transversal, but they actually make it pretty simple here for us. And we don't really have to use it now that I have more information. Because although we can use those angle relationships, we have a triangle in the diagram. I'm outlining it here in blue so you can see it. We have triangle HED right over here in blue, right in the middle of the diagram. And we know that anytime we have a triangle, the 3 angles of a triangle always add up to 180. So if we know that one angle of the triangle is 20 degrees and one angle of the triangle is 60 degrees, we should be able to figure out the third angle. So 60 plus 20 is 80. Subtract that from 180 and we should get 100 degrees as the last angle. So I see here that that's answer choice C. In number 4, they tell us that AB is parallel to CD. So I'm going to want to mark my diagram with my givens. I always want to do that. Remember those arrows that I'm drawing mean parallel. And EF is a transversal. If the measure of angle BEF is 2x plus 60, they drew that in for us. And the measure of angle DFE is 3x plus 20. They drew that in for us as well. What is the measurement of angle BEF? So ultimately, we want to figure out what this angle is. This is angle BEF. E is in the middle, so it's right over here, angle BEF. So in order to figure that out, I want to determine what the relationship is between the 2 angles that they give us information about, the one that we're trying to find and the other one that they tell us something about. So I don't really know much here, but what I do know is that we have 2 parallel lines cut by a transversal. So I'm just going to go ahead and highlight the 2 parallel lines, AB and CD. And I'm going to highlight the transversal as well. So if you take a look at the 2 angles that we have information about, notice how they're inside the parallel lines. They're not outside of the parallel lines. They're in between or within or inside the parallel lines. We call those interior angles. And if you take a look at where they are, they're both on the same side of the transversal. They're both to the right of transversal EF, of line EF. One's not to the left and the other to the right. They're both to the right of the transversal. So we call these 2 angles same side interior angles. If you review your notes, same side interior angles are supplementary, which means that they always add up to 180 degrees as long as we have parallel lines, which we do. So all I'm going to do is make an equation that says this angle plus this angle equals to 180 degrees because they're supplementary. So the first angle is 2x plus 60 plus the second angle, which is 3x plus 20 equals to 180 degrees. So 3x plus 2x is 5x. Combining my like terms, I'll circle the ones that I just combined. And 60 plus 20, that's 80. Combining those like terms equals to 180. If I subtract 80 from both sides, I get 5x is equal to 100. And then if I divide by 5 on both sides, I get x is equal to 20. So the question didn't ask for the x value, though. It asked for the measurement of angle BEF, which, just to remind you guys, is this angle right over here, the 2x plus 60 angle. So all I'm going to do is substitute in the x value that we just found, 20, in for x, and figure out what that angle is. So that's 2 times 20 plus 60. And that gives us 2 times 20 is 40. Plus 60 is 100. So that's 100 degrees for angle BEF. So question number 5 here tells us that ABC, line segment ABC, is parallel to line segment DEFG. So I'm just going to mark that in my diagram so I don't forget. And they also tell us that we have transversal BHE and line segment HF drawn into the diagram. So once again, that word transversal, also the fact that we have 2 parallel lines, that's right away I'm going to start thinking in my mind that we're probably going to have to use our angle relationships formed when parallel lines are cut by a transversal. That's the first thing that comes into my mind now when I'm approaching this question. So they tell us that the measure of angle HFG is 130. So HFG, F is in the middle, so that's right over here, 130. and they tell us that the measure of angle EHF is 70. EHF, H is in the middle, so that's right over here, 70. And we're looking to find the measurement of angle ABE. B is in the middle, so that's this angle right here. So I'm going to put a question mark because we're looking for it. I don't know what it is right now. We have to find it together. So let's think about what we got here and how we can find the answer. So the first thing that I notice is that this 130-degree angle is not inside the triangle. And if you're having a hard time seeing that, let me try to highlight the triangle so that you can see it. There we go. So since that 130-degree angle is not inside the triangle, it's outside the triangle, we call that an exterior angle to this triangle. And we learned in class that anytime we have an exterior angle of a triangle, that's equal to the sum of the two interior angles that are not right next to it. So this 130-degree angle is equal to this angle plus this angle, both of the inside angles that are not right next to the 130 degrees. So if this one's 70, this one has to be 60 in order to make 130. So let's verify that we have that correct. The exterior angle should equal to this plus this. 70 plus 60 is 130. So we have found these two angle measure. We have found this angle measurement over here. They gave us this one. So now we're getting a little bit closer. Now, I don't really see where to go next. So I'm going to go to my parallel lines because that was part of my given information. So I'm probably going to have to use it. And my transversal. They told us in the question that BHE is our transversal. So I want to make this super, super clear. So let me just highlight this part over here. And notice that we have a Z shape. Anytime we have a Z shape, when we have parallel lines cut by a transversal, think alternate interior angles. The two angles that are inside of the Z are alternate interior angles. Why? Because they're inside the two parallel lines. They're within the two blue parallel lines. They're inside of them, in between them, within them. So they're interior angles. And they're on different sides of transversal BHE. This angle that we're looking for is to the left of the transversal, and the 60-degree angle is to the right of the transversal. So those are alternate interior angles. Remember from class that alternate interior angles are congruent as long as lines are parallel, which they are here. We were told we had parallel lines. So if this alternate interior angle is 60 degrees, this one is 60 degrees as well. And there we have it. We have answered the question. That was the angle that we were looking for, angle ABE. In number 6, we have triangle ABC graphed on the coordinate grid here. And we need to find the coordinates of the point of intersection of the medians. Okay. So in order to find the medians, remember that a median, let me write this down. Median connects the midpoint of a side to the opposite vertex. So I'm just going to put that definition here so we can refer back to it during this video. So what I need to do first is I need to find the midpoints of each of the sides of the triangle. So the midpoint is the point that's exactly in the middle, equidistant between the two endpoints of a line segment. So for this vertical line segment BC over here, that's pretty simple. I can count the boxes, 1, 2, 3, 4, 5, 6. Divide that by 2, that's 3. So 1, 2, 3 spaces up right over here is going to be the midpoint of BC. And you can count equally spaced, 3 from C, 3 also from B. So equally spaced exactly in the middle. So I have one median as long as I now take my straight edge and connect this midpoint to the opposite vertex, which would be A. So let me see if I can get a straight line. There we go. And there I have one median. So since the other two sides of the triangle, AB and AC, aren't straight horizontal or vertical lines, I'm actually going to have to use the midpoint formula in order to figure out the midpoint of the sides. So the midpoint formula, remember, is the average of the x's. So let me get my eraser. There we go. So add up your x values, divide them by 2, comma, the average of the y's. So add up your y values and divide them by 2. So I'm not going to show the calculations for the midpoint. You can write down the coordinates here of points A, B, and C. I'll write them down so we're on the same page with that. So A is -1, 2, 3, 4, 5, 1, 2. So that's -5, 2. C is 1, -1, -1. Let's make sure I got that right. And B is 1, 1, 2, 3, 4, 5. So now that we have written down the coordinates, we should be able to find the midpoint of AB and AC. So I'm going to take a second and do that, and please do that on your end if you haven't already. Okay, so I calculated my midpoints of the other two line segments. And for the midpoint of AC, using points A and C in the midpoint formula, I got the point -2, 1/2. So let me plot that. -1, -2. 1/2 would be halfway in between 1 and 2 on the y-axis. So now that I have my midpoint of the line segment, and it does look like it is exactly in between points A and C, I'm going to take my straight edge, and I'm just going to connect from the midpoint. Uh-oh. Let me undo that. Where is my undo button? There we go. So I'm just going to connect from my midpoint to the opposite vertex, which would be B. And finally, the midpoint of segment AB I found to be -2, 3.5. So -1, -2, 1, 2, 3. In between, halfway in between, 3 and 4. There we go. Let me make that a little bit more circular. Okay, as best as it wants me to do here on my computer. So now that I've plotted that midpoint as best as I can, I'm going to take my straight edge and I'm going to connect from the midpoint to the opposite vertex. And I see the point in the middle there where the 3 medians intersect, which is what I'm looking for in this question. Oh, that's why I forgot to switch it back to drawing. I was on line the whole time. That's why it wasn't making dots clearly. So this point here appears to be the point -1, 1, 2. And that's a choice, -1, 2. That's the point that we found where the medians intersect. Okay. In the diagram below of isosceles triangle ABC, AB is congruent to CD. So let me mark that in my diagram as best as I can. So AB and CB are the congruent sides of this isosceles triangle. We know isosceles triangles have 2 congruent sides. So I kind of just like to outline them in the same color. And that way we know they're the same color. So that means they're congruent to each other. We know that they're equal when we look quickly back at our diagram. And we have angle bisectors AD, BF, and CE. So all of these lines drawn into the triangle are angle bisectors, which means that they are bisecting the angles that they're touching, or splitting the angles equally in half into 2 congruent parts. So I know that angle B is being split into 2 congruent parts by the bisector BF of that angle. I know that angle A is being split into 2 equal or congruent parts by its bisector AD. And I also know that angle C is being split into 2 equal or congruent parts by its bisector CE. I just drew a lot of conclusions already. We are off to a good start. In the question, it tells us that the measure of angle BAC So the entire angle here, the entire angle A, that's BAC, where A is 50 degrees. And what we need to do is find the measure of angle AXC. So we're looking for this angle over here. That's what we're trying to find, this angle in green. So since we know that we have angle bisectors here, if this whole angle A is 50 degrees, that means each half of it is 25 degrees. And since we know that we have an isosceles triangle, if we have two congruent sides of the triangle, which we do, we know that AB and CB are congruent sides. We outlined them in purple. And we know that their opposite angles are congruent as well. So if angle A is 50 degrees, the whole angle C is 50 degrees, making each half of angle C, because it's being bisected as well, 25 degrees. And since we have a big triangle ABC, and we know that anytime we have any triangle, all three angles always add to 180 degrees. If the whole angle A is 50 degrees and the whole angle C is 50 degrees, well, 50 plus 50 is 100. So the whole angle B has got to be 80 degrees to make 180. So if angle B is 80 degrees, then we know that each part of it has to be 40 degrees. So now let's take a second to figure out how we are going to get the angle that we're missing. So we just drew a lot of conclusions, we got a lot of angle measurements, and we have to think about where we're going to go from here to get what we want, which is this angle in green. Turns out we can focus on this smaller triangle in the diagram that I'm outlining in red as best as I can on my computer. Remember, anytime we have any triangle, no matter what shape or size it is, all three of its angles always add up to 180 degrees. So in this triangle, we already figured out that two of its angles are 25 degrees. 25 plus 25 is 50. The third angle must be whatever 180 minus 50 degrees is, which is 130 degrees. And that's the angle that we were looking for, angle AXC. So I'm going to write here 130 degrees. And in question 8, it says name the segments that represent the altitude, median, and angle bisectors shown in this triangle. So this is when we're going to have to go back to the definitions of the 4 triangle segments and see what applies to which of the segments here. Oh, an altitude, I'm using purple for that. Remember, is just a perpendicular line through the opposite vertex. So I'm going to write that down, perpendicular line through the vertex. So the only conclusion I can draw from knowing a segment is an altitude is that it passes through a vertex and it forms a right angle with the side of the triangle that it's touching. So if I take a look over here, segment AD starts at the vertex and forms a right angle with the side of the triangle BC that it's touching. So I'm going to write here, segment AD is an altitude of the triangle. Looking quickly, I don't see any other altitudes of the triangle because I don't see any other right angles that are formed in the triangle. Remember, we can't assume anything unless we're told it. So if I don't see any other right angles, I can't assume that, CF is forming right angles or anything like that because I don't have the information to conclude that. We talked about what a median is before, so I'm not going to rewrite it because you can still see it over here. A median connects a midpoint of one of the sides of a triangle to the opposite vertex. So I see here congruence marks on each half of side AB of this triangle. That lets me know that side AB is being split into 2 equal or congruent parts. So F is the midpoint of side AB. It's the point that's splitting the line segment in half or into 2 equal parts. Since F is the midpoint of side AB, and this line segment over here connects to the opposite vertex, which is C, FC is a median of the triangle. I don't see any other medians because I can't find any other midpoints for sure of any of the other sides of this triangle. Nowhere does it tell me that side BC is being split equally into two congruent parts, and nowhere does it tell me that side AC is being split equally into two congruent parts. So I just can't draw the conclusion that D is the midpoint of side BC or that E is the midpoint of side AC. Very important not to trust the way the diagrams look and to only go based on what information you actually have and are given. Okay. Angle bisector. So we talked about this in the last example a little bit. So an angle bisector cuts an angle into two equal parts or two congruent halves. It bisects an angle, splits it equally in half, two equal parts. So I'm going to look for something on the angle, some indication that an angle is being cut equally in half. And I don't see any marks on angle A. I don't see any marks on angle C, but on angle B, I do see these two congruence marks that I'm outlining in green. That lets me know that angle B is being cut into two equal or congruent parts. So I see angle B is bisected here. So the segment that's bisecting angle B is segment B. And that would be the angle bisector of angle B. What is the equation of a line passing through the point 2, -1 and parallel to the line represented by the equation y equals 2x plus 1? So remember, parallel lines have the same slopes. So we want a line, the equation of a line that has the same slope as the one that we were given and that passes through the point 2, 1. So the slope of the line that we're given is 2. Remember, the slope is what's attached to the x when you have the equation in y equals mx plus b form. So 2 is the coefficient on the x. I'm going to write the equation of the line in point slope form. So point slope form is y minus y1 equals to m x minus x1. Remember, when you're plugging into point slope form, all you need to do is plug in the slope for m and plug in the x and y coordinates of the point that you're using and for x1 and y1. So we have y minus the y coordinate of the point that we're using that we're given is -1 equals 2. The slope is 2 because remember, it's parallel lines have same slope, so same slope as the original line. Parentheses x minus the x coordinate of the point that we're using is 2. So you can stop right here. This is a perfectly valid equation of the line because the question doesn't say to solve for y or put the equation of the line in slope-intercept form. If the question did ask, then you would have to take it a step further and solve for y. So I'll show that now just in case you're asked to do that. So y minus 1 is y plus 1 equals 2. Let's distribute the 2 to everything in the parentheses. That's 2x minus 4. And finally, let's subtract 1 from both sides. We have y equals to 2x. -4 minus 1 is -5. So either equation works that's starred. They're both equivalent. The top one in green is just in point slope form, and the bottom one in red is in slope intercept form, or y equals mx plus b form. They both, either one of them would get you full credit if the question doesn't specify how to leave your answer. The next question says that line segment NY has endpoints n, -11, 5, and y 5, -7. And we need to write the equation of the perpendicular bisector of NY. So 2 parts there, perpendicular bisector. So remember, perpendicular lines have negative reciprocal slopes. And remember that bisectors, since they cut a line segment in half, they always pass through the midpoint. So we're going to need 2 things here. We're going to need our slope. Once we have our slope, we're going to have to take the negative reciprocal of it because negative reciprocal slopes for perpendicular lines. And we're going to also need our midpoint because that's the point that the bisector always passes through. So first, let's find the slope, and then we can work on the point. So remember slope formula is y2 minus y1 over x2 minus x1. So let me plug in really quickly. So our y values are -7 and 5. And our x values are 5 and -11. So -7 minus 5 is -12 over 16. And to reduce that into simplest form, that's -3 over 4. So remember that since perpendicular lines have negative reciprocal slopes, to get the perpendicular slope that we're going to be using for the equation of the line, we're going to have to flip the fraction that we got for our slope and also change the sign. So when I flip the fraction, I get 4 over 3 instead of 3 over 4. And since it's negative, I'm going to change the sign to positive. So that's positive 4 over 3 for our perpendicular slope, our negative reciprocal slope, and that's the slope we're going to be using for our perpendicular bisector equation. The next thing I need is the midpoint, because remember, perpendicular bisectors, anytime you have a bisector, passes through the midpoint. So that's going to be the point that we're using. So by now, we've wrote it down other times in this video. We should know that midpoint formula is average of the x's comma average of the y's. So I'm going to plug in really quickly. That's -11 plus 5 over 2. And that's 5 plus -7 over 2. I'm running out of space here. Oh no. My brightness keeps changing. I keep leaning on all the buttons. So that's -6 over 2, which is -3. And 5 plus -7 is -2 over 2 is -1. Okay. So now that I have the slope I'm going to be using and the point, all I need to do is plug into point slope form. So use a different color. So remember that point slope form, and I'm trying to get some more space here, but I'm kind of running out of space. Let me see if I can move some stuff over. Okay, that's as best as I can do. So point slope form is, let me go back to drawing, y minus y1 equals to m x minus x1. So remember, we're going to plug in our x and y coordinates for x1 and y1, and we're going to plug in the slope that we're using for m. So that's y minus the y coordinate of our midpoint, which is the point that we're using, is -1, equals to the slope that we're using is the perpendicular slope, which is 4 over 3, parentheses x minus the x coordinate of the point that we're using, which is -3. So I'm going to box this answer because I'm out of space. You can definitely stop right here. Of course, minus minus 1 is plus 1, so you can write this as y plus 1. And minus minus 3 is plus 3, so you can write this as x plus 3. But you don't have to take it a step further and solve for y because the question didn't specify to. But if it did, you can distribute the 4 over 3 to each term inside the parentheses and continue solving for y. But the question here does not specify, so this is a perfectly valid and correct equation of the perpendicular bisector of ny. In the diagram below of triangle MNO, angle M and O are bisected by MS and OR respectively. So I'm going to stop right there. That's a lot of information. So both angle M and angle O are getting bisected. So that means that they're getting split in half into 2 equal parts. I'm going to mark that in my diagram. Angle M is being split into 2 equal parts, and angle O is also being split into 2 equal parts. I like to use different colors so that way I don't lose track of things. You can also use different colors on your test. You can use any colors that you want and as many colors as you want. Segments MS and OR intersect at T. I see that in the diagram. They do meet at point T. And the measure of angle N, which is right over here, is 40 degrees. So if the measure of angle TMR, so TMR, M's in the middle, so that's right here, is 28 degrees. Let me write that into my diagram. The measure of angle OTS is what? So OTS, T's in the middle, so that's right here. And I put a question mark because that's what we're trying to figure out. So let me just fill in some stuff that I know already. So if that's 28, since M is being bisected, that's 28 also. So that means that the whole entire angle M, and I'll just write it over here as 28 plus 28, that's 56 for the entire angle of the triangle, for angle M. So in triangle MON, or MNO as the question says, in the whole big triangle, we now know two angles. We know the 40-degree angle that they gave us, and we know that angle M, the entire angle M, is 56 degrees. So we can figure out what angle O is because we know in a triangle, all three angles always add to 180 degrees. So let me do 40 plus 56. That gives me 96. And subtract that from 180, and I get 84. So I know that the whole angle O is 84 degrees. And I know that angle O is being bisected. They told us that in our given, so it's being cut in half. We marked the two equal parts in green. So if it's being cut in half, 84 divided by 2 is 42 degrees. So each half of angle O is going to be 42 degrees. So there's multiple ways to get to the answer from here to figure out what angle OTS is. So I'm just going to go with the way that sticks out to me that I see first. So I noticed that there is a smaller triangle over here that I'm outlining in black. And I already know two angles of this triangle, the 28-degree angle and the 42-degree angle. So I can find what that third angle is of the triangle, since once again, all three angles of any triangle always add to 180 degrees. So I can do 42 plus 28, that gives me 70. And if I subtract that from 180, I get 110. So I just figured out that this angle right here is 110 degrees. And now notice that this 10-degree angle is supplementary with the angle right next to it. They form a straight angle or a straight line. They add up to 180 degrees altogether. So if I do 180 minus 110, I should get the angle that I'm trying to find, the angle with the question mark. So 180 minus 110 is 70 degrees. So angle OTS is 70 degrees. We did it. Okay. In the diagram below of triangle ABC, BC is extended to D. Ooh, so we have an angle that's outside of the triangle. I see that in the diagram already. If you see that, a side of the triangle is extended somewhere, that's a keyword that you're going to have an exterior angle. So they tell us that the measurement of angle A is x squared minus 6x. The measurement of angle B is 2x minus 3, just filling in from the givens. And the measurement of angle ACD, C is in the middle, so that's right here, the exterior angle, is 9x plus 27. And all it's asking us to do is find x. So in order to answer this question, we can use the exterior angle theorem of triangles, which says that the exterior angle of any triangle, so that's 9x plus 27, that's the exterior angle here, is equal to the sum of the two non-adjacent interior angles. So the sum of the two interior angles that are not right next to it. So this interior angle is not right next to it, and this interior angle is not right next to it. So this angle is equal to this plus this. So x squared minus 6x plus 2x minus 3. So let me get combining some like terms. So I see two like terms over here. Let me clean this up a bit. So that's still here 9x plus 27 is equal to x squared minus 4x minus 3. Let me just erase that because it doesn't really look like 4 and I don't want any confusion with that. There we go. And I see already that my largest exponent is 2. I have something to the power of 2. That's a quadratic equation. I hope that brings back memories from Algebra 1, maybe happy memories, maybe unhappy memories. I'm not sure. But we have a quadratic equation. So remember that one way that we can solve quadratic equations is by factoring. But in order to do that, your equation has to be equal to 0. So what I'm going to do is I'm just going to subtract 9x from both sides and subtract 27 from both sides. And that way, everything can be equal to 0. So 0, because I moved everything away, is equal to x squared. So negative 4x minus 9x, that's negative 13x, if I am correct there, for negative 4 minus 9. Yes, okay. And negative 3 minus 27 is negative 30. So in order to factor this quadratic, what I'm going to do is I'm going to look for 2 factors of 30, of negative 30, I should say. So 2 factors of negative 30. So that means 2 numbers that multiply to give me negative 30, but they also have to add up to give us negative 13, the middle term. So let's try out some values. So I'm thinking of factors of 30, of negative 30. So the first ones that come into my mind are negative 10 and 3. So let me write that down. Negative 10 and 3. So these multiply to give me negative 30, which is what I need. But if I add them together, negative 10 and 3 would give me negative 7. So that's not negative 13. That's not going to work. Let me try positive 10 and negative 3. So if I multiply these together, I get negative 30. But if I add them together, I get positive 7. And that's not what I'm looking for here either. So let's think of other factors. Maybe 15 and 2, that multiplies to give me 30. So maybe negative 15 and positive 2, that multiplies to give me negative 30. Oh, and when I add them together, I do get negative 13. So we found the factors. Woohoo! That's a guess there. Totally fine. So negative 15 and positive 2. So remember that we switch the signs, because if you take each one of these and set them equal to 0, the sign changes. So our 2 x values here would be negative 15 minus 15 changes to positive 15 if you add 15 to both sides. Not going to do out all the steps, you can just switch the sign. And since x is positive 2, it would be negative 2 if we solved. So we're going to reject the negative because we are dealing with a triangle, which is a real life shape. So negative values just don't make sense. And we're going to go with the positive x value of 15. And there we have it. And don't worry, for those of you who are super scared, I didn't put factoring on the test. But factoring is a good skill to have, and it does come up sometimes. All the questions that you see on your review sheet and also on your test that you take, they're past Regents questions. So that means factoring has come up on the Regents before. Even though it's an Algebra 1 skill, stuff like that does come back. So it's a good thing that we're reviewing it from time to time and seeing it again. So make sure that you try that question again if you didn't get it the first time. Make sure that you also study constructions of equilateral, isosceles, and scalene triangles. Constructing angle bisectors, medians, altitudes, and perpendicular bisectors of a side of a triangle. And also constructing parallel lines. All of those constructions can be found in the constructions Edpuzzle video that is posted under the resources section. Make sure that you also study the angle relationships formed when parallel lines are cut by a transversal, like alternate interior angles, corresponding angles, same side interior angles, etc. Remember, those angle relationships only hold when lines are parallel, but most of the time in questions, they'll tell you that you have parallel lines, just like the ones on the review sheet that we saw before. So the angle relationships can also be used to prove that lines are parallel. For example, if you can find a pair of alternate interior angles that are congruent, then you can actually prove that lines are parallel. So that's just something to keep in mind as well. Good luck on the test, everybody. Hope you found this review video helpful.